So let's come to this three-point shot. Well, a three-point shot has some horizontal component to its motion. But Galileo's analysis allows us to treat the horizontal and the vertical completely separately. So it's moving at a nice constant velocity in the horizontal component, but the vertical component is quite separate. So let's imagine a vertical ball tossed like this. Now, I do apply a force to the ball with my hands to give it that initial speed. But the moment my hand is no longer in contact with the ball, there's no way I'm applying a force to it. But we still feel this kind of sense that, well, if something's moving, there must be a force to it. Well, that makes sense. A person called Aristotle thought that thousands of years ago, that force causes motion. And it's natural to think that, because everything we see in our world, if you stop pushing it, it eventually slows down and stops. That's because there's resistant forces of drag and friction making that happen. No, it was Newton's genius to realize that force causes a change in motion. And so the weight force on this ball, because that's the only force left on it once my hands are no longer making contact, is causing it to change its motion in the downwards direction, even while it has still an upwards velocity, because that upwards velocity is becoming kind of more downwards every second. It's becoming less and less each second as it travels up. And so as our ball, once it leaves our hands for that entire flight, the only force on it is the weight force, and therefore the only change in its motion is going to be the acceleration downwards.
So let's have a look at that downwards acceleration. This is done using Tracker, which is a free piece of software you can download from the internet. The bottom graph is the critical one here. It's the velocity versus time. And you can see that the velocity versus time for the entire motion, all the way up and all the way down, is a straight line with a negative gradient. That's because it's accelerating downwards, and that's the only acceleration.
The other moment in time perhaps worth sort of thinking about for a second is that moment in time where it's at the top of flight. And there's a temptation to feel that if something has a zero velocity, it must have a zero acceleration. But of course, if that was true, right now I've got a zero velocity and maybe you do too. And if that was true, none of us would ever be able to leave the spot we're in.